Hello, honors algebra students. Here's the second part of the review where I'm going to deal with some parabolas and just by using the quadratic formula. Okay, so first off, right off the bat, I've got y equals at negative x squared plus 5x minus 7. And I notice that here we have a negative. I know my parabola is going to be opening downward. Now, remember, in the previous video, I mentioned things that you can do. And I'm going to do them. First, I'm going to find the discriminant. So I'm going to go A, B, and C. And B squared is going to be 25. I've got minus 4A, C. And 25 minus 28 is going to be less than 0, so there's no solutions. So at this point, I don't go use the rest of the quadratic formula. I'm going to use x equals negative b over 2a to find the x-coordinate of the vertex. So I'm going to get negative 5 over negative 2. So the x-coordinate of the vertex was going to be 2.5, I believe. To get the y-coordinate of the vertex, I'm going to plug that in. Negative of 2.5 plus 5 times 2.5 minus 7. And I know that's going to be 625, negative 6.25. 10 and 2.5 is going to be 12.5 and a negative 7. This is going to turn into 6.25 minus 7, which is going to equal negative 75 cents, so to speak. So I'm going to go to 1, 2.5, and then negative 3/4. Maybe a little bit lower than that. There we go. That looks a little bit better. And now I'm going to go to my t-table, and I've got x and y, and I'm going to put my vertex in. What was it? 2.5, and then negative 3/4. Sorry, 75 hundredths, 3/4. Now I'm going to put 0 in. Oops, I have a mistake, don't I? I went to negative 2.5. That should be a positive 2.5. There we go. That's where that belongs. And now I'm going to put 0 in. And when I do, I believe I'm going to get negative 7 out. All right, negative 7. And I'm also going to put 5 in, and that's going to yield negative 7. So I'm going to go 0, negative 7, 9, 8, 7 right there. 1, 2, 3, 4, 5. Yeah, that's looking pretty parabolic. Let's see if I can get half of it drawn well. That's not too shabby. And then I will clone him, flip him, and there we go. There's our parabola. All right, next one. Again, I've got a negative for A, so I know it's going to open downward. So A is negative 2, B is negative 3, and C is 4. And then we are going to go for the discriminant. So B squared is going to be 9 minus 4 times negative 2 plus 4, times 4, excuse me. So we get 9 plus 32 is 41. There is going to be two solutions to this. So I'm going to continue. Well, actually, I'm going to go ahead and find the x-coordinate of my vertex, which is going to be 3 over negative 4, I think. So negative 3/4 is the x-coordinate of my vertex. So now I'm going to find the y-coordinate. I know the x-coordinate is negative 3/4. I'm just going to plug it in. And so I'm going to get negative, oops, I'm not in right mode, pardon me. Sorry about that, I actually took a little lunch break there. Negative 3/4. Excuse me, minus 3 times negative 3/4 plus 4. Right, and those are going to be the y-coordinate of my vertex. So what's that going to be? Is it going to be 1.5? Yeah, I think so. So 1.5. And this is going to be negative 9 or positive 9/4. Oh, I forgot to square it, didn't I? I have a mistake there. Sorry about that. So let me see here. I'm going to get 9/16, and so I'm going to get 9/8. I think it's going to be a negative 9/8, right? Okay, and then here I'm going to get a positive 9/4 plus 4. Now, these are 9/8 is half of 9/4. And so if I take half of 9/4 away, I'm going to be left with a positive 9/8 or a positive 1 and 1/8. Okay, plus 4 is going to equal 5 and 1/8. And I know I'm supposed to get two solutions, and this is opening downward, so I'm feeling good about this. So I'm going to get negative 3/4. And I go 1, 2, 3, 4, 5, and an 8. So it's going to be pretty close, right about there. Okay, now I can use the rest of the quadratic formula to get the roots. All right, so I've got the negative of b, well, x equals the negative of b plus or minus the square root of, I believe it's 41. Remember I found the discriminant earlier, I'm not recalculating the whole discriminant. And 2a is going to be negative 4. And so now I'm going to go to my calculator, and I'm going to get 3 plus the square root of 41, and I'm going to divide that by negative 4, and that's going to come out to be about, so it's going to be approximately equal negative 2.35, 2 and 35 hundredths. And then I've got to do 3 minus the square root of 41 and divide that by negative 4. And I'm going to get about 0.85. So let's see, negative 2 and a third, somewhere around there, and then 0.85 is going to be 85% of the way, getting pretty close. And doesn't look quite right. Well, I guess it's close. I mean, it's really hard to graph these accurately with these decimals I'm dealing with. So I'll get that. And then the other part I'll do something like that. All right, one more example, and then we'll wrap this video up. Okay, so I know it's opening downward. I'm going to go and check and see how many roots it's going to have. Now, I know, because I made up the problem ahead of time, this is actually a perfect square trinomial, but most of you would never recognize it as such. And that's okay, but I'm expecting to find one root. So I'm going to square 9, and then minus 4 times negative 1 times negative 2.25. Yeah, I'm expecting that that's going to come out to be 0. 9 minus 4 times negative 1 times negative 2.25. And sure enough, I do get 0. So there's one root. Okay. So I'm going to go find the x-coordinate of the vertex. Negative b over 2a. And so the x-coordinate of the vertex is at 1.5. Now, the y-coordinate is 0 because there's one root, and that means the vertex is on the x-axis. So I don't need to do a whole lot of work. I mean, in a way, these are the easiest ones because I'm going to have 1.5 in for x, y is 0. Now I'm going to plug my 2 points in for x. I'm going to put 0 in, and that's going to get me out a negative 2.25, right? Negative 2.25. And then I'm going to go 1.5 on the other side, which is 3, and that's going to be at negative 2.25 as well. And so 3, 2.25, right about there. And see how little time that one took? Some of you have such a hard time with some of these problems, but you're having a hard time with the easy stuff. Okay, so let me get that drawn. And then this side I'll do something like that. Okay, and that's it. So remember, if there's one root or no roots, you're going to use a t-table. Use friendly numbers. Okay, obviously you have to find the x-coordinate of the vertex, but when there's one root, the y-coordinate is automatically 0. So there really shouldn't be any trouble getting this type of problem wrong. You should be able to, in the root ones, everybody should be getting this right. It's too simple not to. The one that has the most amount of work is the one where there's actually two roots, and you have to find both of the roots. Now, I know on the test, Miss Eubank will be expecting you to um, find how many roots, find out what the roots are, find the vertex, and then graph them. Okay? Oh, I think no, I think I'm forgetting something here. You know what I think I forgot to do on that one video? I forgot to do the parabola, so I'm going to do, hold on just one second. A thought just occurred to me that when I graphed this one for you in the first video, I talked about it being broken, I talked about shading, and I don't think I did either of that. I think I was in too much of a rush. I apologize for that. I'm going to go ahead and do this one really quick. I'm going to do it by factoring. I'm going to know that's a perfect difference of perfect squares. So I'm going to factor it like this. And you'll remember that the roots are at 2, 0, and negative 2, 0. And then, of course, the vertex was at 0, negative 4. 1, 2, 3, 4. And I'll bet if I go back and watch that video, I forget to do the rest of it. And I sure am sorry about that. Okay, so now I'm going to draw my parabola. And it's a broken curve because it's not equal to, right? Okay, now I'm going to use my test point. Remember, for an inequality, there's a test point. Then I'm going to plug 0 in for y. I'm going to plug 0 in for x and see if I get a true statement. 0 is greater than negative 4. That is a true statement, so I am going to shade inside this parabola. So my solution will be everything inside the bounded u. Okay, the u is my boundaries. The u is not included, and that's, how do I know that? Because they're broken. But that's what I do. All right, now, I'm not going to take up any more time in this video. Just to say that when you have an inequality, remember you have to have a broken parabola, and there has to be shading. All right, Mr. Lawrence signing off. Have a good night, everybody.